Right, so in this one, I'm going to go through 1.3 exchanging data and this part of the course. So, first of all, let's go to it. So, circuit switching. What is circuit switching? Well, circuit switching is where you would physically change the path electricity takes, basically, like a physical switch has happened. Well, the path the electricity takes has changed, the connection has changed. So, in the old days, for example, on telephone connections, you would all have a wire to the telephone place. I can't remember what it's called. And then a lady or man, but normally it was a lady, would reconnect you with a wire to the one that you wanted to speak to, and then that would be circuit switching. Okay, so you're literally switching the circuit between one and another like that. Okay, so that's circuit switching. Packet switching is logically switching the route something takes. So the key difference is one is connectionless, whereas circuit switching is connection orientated. So, for example, let's say with logically you're connected, you have 10 connections already, you're choosing which one to send the data down. With circuit switching, you would make the connections would actually change, like you'd actually connect to different ones. So, okay, why do we need packet switching? Well, what packet switching normally to do with is a data packet, hence packet switching. So what is a data packet? Well, you would never send a large file like 1 GB in one go because it might go wrong. You have to resend it all. It probably slow down. The route might need to change. So you break it up into small things called packets. Okay. So first thing is what's in a packet. Well, it's three parts. There's the header, the payload, and the trailer. The header has these things in it. Okay. The IP address of the person who sent it, where it's going, obviously. The protocol used, the packet number, and the total number of packets, so it can be reassembled at the other end. The data itself, and then a trailer, which can have some error checking or just some end of data stuff. It's called cyclic redundancy check. It's a common one. So they'll do some math to all the packet data and get a number. And then as long as the computer at the other end does the same math and gets the same number, there's not been an error. Okay, or at least probably not an error. So that's what cyclic redundancy check is. Okay, so packet size. Packets are kept small to ensure they don't take too long to get to destination. But you don't want them too small because you don't want the percentage of header and trailer to be too much. Like if you've got 1 byte in it and then this is 20 bytes or 30 bytes or whatever more. The percentage of how much the data is compared to the header and the trailer. About 1K is normally common. 1 to 1.5K is normally the size of a packet. But it can vary to whatever they want to do. So packets can take different routes as they go on they're switched onto different routes. So let's actually I should have probably sort of imagined these are like routers. Okay, here. These are loads of routers. Okay, and the packet would go down one path to a router. It would get here, and then the router would decide where to go. And as it bounces from router to router, this is called a hop. Yeah, so every time it goes down to a router, obviously that cable should be connected, but I drew it before. I don't know, I'll try and, there you go. As it goes down the path to another router, it gets here, this router tells it to go to this router, and this is called a hop. Okay, so how does it work? Well, this is called routing. So what happens is a router will forward data packets from one network to another. So that's what they do, they forward data packets on. Each router has got inside it something called a routing table with information about how to get to further down the network. So this router might have a table of all of sort of where these things are or how to get there at least. So what would happen is the packet would get here, it would look at the IP address and it would say, right, you want to get here, I think the next best route is for you to go here, and it would route you off to this router. It gets to here, this router would look at its routing table and suggest the next current stop. Obviously in this case it's here because it's destination, but this is a very simple idea. So when a router receives a packet, it will look up destination IP in the routing table to find the best route to forward the packet to. Every time a router pushes the packet on, it's called a hop. This repeats until it gets to the destination, right? So packets are sort of sent off on their own little journey. You send it out to the first router, and then each router goes, right, you have it, you have it, you have it, here we go. Okay. So if by the way, a packet doesn't make it because, this computer could get crash or whatever, then it would be up to the protocol to decide what to do and how long to wait and whether to ask to resend it and things like that. Some protocols don't resend, like in the terms of UDP, because that's used for gaming and video streaming, and it's just no point asking for the frame to be sent again because you're probably better off just skipping the frame or whatever. Some like TCP/IP and others will ask for the packet to be sent again. Anyway, so What's a gateway then? Right. Well, a gateway is, what if this packet is in TCP, but we need it to be in FTP or something like that. We need to change the protocol used, okay? You would use something called a gateway. And what a gateway will do, right, because bear in mind, so you've got the data, and the data's in the middle, but the protocol could be different. So what a gateway will do is it will strip away the header, it will strip away the tailor, it'll take the data, it'll make a new packet in the new protocol format, and then forward it on. So a gateway's job is to alter a protocol used from one to another. Most routers incorporate gateways in them, right? So they all have a gateway inside them, really. So you don't normally have a secondary thing. You just have this part of the router, just called a gateway. But I suppose in the old days you probably could get separate ones, but modern, no. Anyway, so we're now going to look at something called the 4-layer TCP/IP protocol stack. It's quite a complicated bit, quite boring-y, but here we go. So what's the point of layering in networking? Well, the whole point of having layers is that you have a standard that says about what comes in and what goes out, right? And by doing that, it means that you can break down the job of sending data over a network. And if, for example, we want to improve this layer doesn't have to know that anything's happened, and this layer doesn't have to know. We just improve this layer, and these two don't notice. Because as long as the data coming out of here and going into here, and the data coming out of here is the same as it was before, which it would be, then you don't care about what happens in that layer. So you can sort of decompose it, and it's a level of abstraction. This thing doesn't care about these things, and this thing doesn't care about these things as such. Okay, that's the reason of have layers, right? Yeah, there you go. And these are the layers you've got to learn. So what do they do? The application layer. So the application layer is responsible for managing the communication between software, applications, and network. Basically, what it does is it selects the appropriate protocol for the application it's using. So the web browser, it might choose HTTP, POP3, or FTP in different situations or others, but they're the main ones. So the application layer, its main job is to select the appropriate protocol for the application that's using it, right? The transport layer is the thing that splits the data into packets and numbers them in order. And it's the one that adds the packets to the header and decides the port it will travel. We'll talk about what the port means, which we'll talk about again in a minute. But a port basically allows the computer at the other end to know which program this data is supposed to go to. So, for example, web pages use port 80. So if the application is looking at port 80, the data will get sent, and then, that's what a port does. It basically tells you what application or service is going to use that thing. Yeah, so it adds the packets to the headers and decides the port it will travel through, and if any packets have been lost in the connection, the transport layer requests retransmission. So because it's a stack, so it goes down one way and up the other at the other end. Okay, stack goes in and then it's popped off from the top. So we've done ports. Okay, so think of ports like a doorway. Yeah, that's it. And network administrators can block ports to disable services like Netflix. Okay, so each application or service uses a different port number to ensure that data packets heading in and out of the device correspond to the correct application or service. So we're now on the internet layer. I mean, you can just read these really. It adds the IPs to the header. Routers operate on this layer. As we now have an IP address and a port, this forms what is called a socket. So a socket is the IP address and the port that's being used for data packets. So now a socket decides where the packet is going, IP, and what application is using it, port, right? Link layer adds the MAC address of the network interface cards of both the source and destination computers. This means that once a packet, not one, gets to destination, it goes to the correct hardware. So it basically knows which hardware it should go to. The destination MAC address changes with each hop. It is only the address of the next step in the journey. So on here, this would put the MAC address of this router as destination, and it would keep going until we get to here. Just keep going, adding the MAC address of the next hop. Okay, where are we up to? Okay, so at the end, the process is done in reverse. The link layer takes away the MAC address in the packet. The internet removes the IP address. The transport layer removes the port and the packets, and it will put it in order. And the application layer uses the data in its application, right? So you might want to go back and have a little look at some of the slides. I've gone through it quite quickly. But yeah, there you go.